Hello guys, this is Expert Panda and if you are watching on YouTube, so let's understand today's question that we have is 704 binary search. So we have already seen this one on the Expert Panda. Let's revise this one with more approaches, right? So first we have is 704, right? And it is saying that we have given an integer array and that is known as nums, so which is sorted in ascending order, right? It is sorted in ascending order. We have given integer target and write a function that we call search, right? Search target in nums, right? We have to search a target in num that we have to develop. If the target exists, means we can find, right? Then we have to return that index, otherwise we will return -1. So you must write an algorithm of O log n, right? Because we are doing search, so we have to take O log n, not O of n, okay, and any other. So if you'll talk with the example 1 right here, so we have given num, right, and we have given what target we have given, okay. So nums we have given like this and target we have given like this, okay. So what we will do, we will represent into the you can say array. So I'll take first -1, then what we have 0 we have, then we have 3 we have, 5 we have, 9 we have, and 12 we have, right? So if I'll represent this one into array, it will look like this, correct? Now we have to find target, right? So target is 9, okay. Now this is your array, this is your array, and this is the search item, right? Your search item. So this is known as what? Nums, and this is your target search, right? And we have to develop what? We have to find this 9 into this array. So what we will do, this one approach in which what we will do, you will start from here and one by one we will check. First we will check in here, then we will check here, right? One by one we will check and will complete till here. So once we will reach here, we will see, oh, we find the element, we will return. So but what you will see, we are visiting all these indexes, right? So it is actually, it is not required, right? So what we have to do, we will use the binary search, right? In the binary search, what we have to do, we will divide this one by half. So if this is starting index and this is ending index, okay, so what we will do, we'll add 0 plus n, let's suppose, whatever the index. So for this you can see what is 0, 1, 2, 3, 4 and 5. N is nothing but a 5. So 0 plus 5 will do by 2 will do. 0 plus n by 2 you can say will do divide, and will it is coming on 2.5, so we'll consider 2, and this is nothing but our mid, right? So from here we will divide. So from 2 we will divide this one, right? This array. So we will not search this part. Why? Because if mid is mid at you can say array at mid, sorry, array at mid is what we have, array at mid is, let's suppose anything you will take, right? Either 3 or 5 you can take. Let's suppose I am taking 3, okay. So it is nothing but 3, and if it is less than the search item, that is what, 9, it is less than, so we will not going to search here. Why? Because we know that this is sorted item. If 3 is smaller, right? So why will go to there? Because we know that there will be no value here or here, it will no value, okay. So we will not going to search in this part of the array, okay. What we will do, we will search only this part of the array, okay, here, and we will find here, and that's why it will become O log n. I think you got me, okay. So the problem is that what we have to do, in the, you have given an array, from that you will divide the array of first you will divide by them on the mid, and on the mid you will check, we have to find here or this way, right? If we are going to find this one, so you have to discard this one. If you are going to discard this one, so you will search into here, right? Like that each time it will do. I will do recursively, will find this one, right? So many ways we have that we will talk about this one, okay. So we find this on where, on the 9, now on the 4th index. Now we have target 2, right? So target 2 is not in here, right? So what we'll do, we'll return -1. Got it? Now we'll talk about constant, right? What is constant? So constant, we'll see. So constant norms of length should be greater than equal to 1 and it should be less than equal to 10. Length should be greater than equal to 10 to the 4 and it should be less than equal to num of I, right? And target should be less than equal to 10 and get them to this. This is should be the range. It should be all integers should be unique, so that we will divide by half and then we will find which part of the value we have to go, right? Then we will talk about ascending. And one more thing, if there is multiple position, right, so it will be confusion which index we have to return, right? So nums is because it is not saying the first search we will return or last search we will return, so it should be unique. Next is saying that nums is sorted in ascending order, and that we already knows, right? Now we'll talk about you can say this question has been asked in multiple times in Google, Amazon, Apple, Adobe, Microsoft, Facebook, right? So all top companies are asking this question, right? So you should at least do hands-on at least one time. And similar questions after doing this, you can do practice of the binary search. Is search in sorted array of unknown size. Another maximum count of the positive integer and negative integer. It is available on the lead code. If you are not able to find, please ping me in the comment box. I'll provide that one. Okay. So let's go and see what is binary search. So first of all, binary search is one of the most you can say important and fundamental useful algorithm in the computer science, right? So it describes the process of searching for a specific value in an ordered collections, right? And terminology that we use in binary search is, you can say, target, index, left, mid, right? That we will use. So what is target, right? That we are talking about, we will create one array, right? And we will take what left, will take left, right index will do mid, we will find our mid, right? So these things we will talk. And target, that we are going to search into here, correct? So target is the element that you are going to search, right? And index, you know that index, each index is here, right? Each index is here, right, into the array. And left and right is the indices from which we use to maintain searching the space. We can start searching from here to here, right? So this is our left and this is our right of the searching space, correct? Now what is mid? Now the mid is the indices that we use to apply condition to determine if we should reach that left to right, right? Left or right, you can say that you know this one. So there is multiple ways in which you can do the solution, right? The first way, we will understand find the extract value, right? And if you really want to understand other approaches, you can ping me in the comment box. I'll provide the video. Okay, let's understand first extract value, right? So if we have given this target, right, let's suppose this target is given, and this is your left and this is your right, right? So here you have to determine the boundary for left and right, right? So where we will go. So target is 9 that we are talking about, right? So if this is left, right, so we'll start from here 0 1 2 3 4 5 6 7, right? And then you know that left is what, 0, right is what, 7. We'll do sum, left plus right is nothing but 7, and now we will divide by what, 2. We are going to divide, it is coming 3.5, right? So this will be your mid. What is your mid? Let's suppose you can take upper layer also, lower layer also. So I'll take lower level, right? 3.5 is nothing but 3 will take. Okay, sorry, here, right? So this part, this is our mid. So this part we are not going to search now. This part we are not going to search now. Okay, right? Because first we will check on the mid. If element at mid, that is 0, right, and what we are searching, 9. So 0 is less than 9. In that case, we are not going to search this half part of the array, you can say. So we will search only this part. So now we will go to check and we will find here what, 5. First is 3, no, not equal. Next we will move to next here, then we will check here, right? Like that we'll do. Okay, so you can consider also here, if we'll do this one, right? So we'll divide again, we'll check this side or this side. right? So we'll ignore this one, we can check this one only. So at the mid we will find 9 and then we will return. Got it or not? Let me explain again. I'm talking like first we will we are dividing from here, right? So we know that this part is not useful, this part is only useful. Now the array is look like what? 3, 5, 9, 12, right? So again what we will do, we'll take left and right and mid, right? So this is left, this is right. So for this one, what is the index? It is, let's suppose it is 0. This is what some value 0, 1, 2, 3, 4, right? So what we will do, we will divide this one, right? From here we can divide from here. So this part we are not going to search, this part we will going to search. So this is your mid for the next divide, right? And that's why, or the mid, you will find this one. So this way you can find the element. Let's suppose how we are understanding. So if search item is 9 at somewhere at the mid, right? So what we will do, we'll get the middle index first. You know how to do, left plus right by 2 will do, we'll go get your middle index, right? Now what we'll do, we'll compare the value a at mid is equal to target, right? There will be 3 cases. If it is matching, if the value is at the mid, 9 we are searching and we have the element at 9 mid, right? That what we will do means our if a of mid equal to array of mid equal to target, means we find the target in the array. Now what we will return, we'll return our mid, okay, because this is the index where we find the element, correct? So this mid index will find and will return. Now if mid is mid at this one is left, right? Then what we will do, we'll update our left. So now left is not here, it will move from here to here. Now this, because this part is discarded, now only we'll consider this part, right? So from here left will consider to right till here. Now what we will do, if this case is not matching, let's suppose this case is not matching, this case is not matching, the third case will create this one, in which we'll check if mid is less than array at mid is what, less than target, okay? So we should discard the you can say larger half, and we'll say right is mid minus 1, right? So first you should always check if mid is equal or not. If not equal, then we have to update our left and right as well, okay? It should be greater than, if mid is greater than target, like this, okay, like this, okay, leave it, you will understand. Like this you can say, okay, like this. 3 cases we have, like this will. Now think about this one. If element we found mid, this and this, right? We will divide, actually we are dividing again and we are finding, right? So in that case we'll check left, we are updating actually like this. So we will cover all the cases, and similarly we'll update our left and right. From initially it will the array will be big, it will update each time, okay? I think you got it. So what you will do, we'll take we will initialize left, right is what given array size -1, correct? And if the element is in the left and right, then we will find our what, mid we will find, and we'll check the element. If mid is greater equal to target, we'll return mid. If array at mid is target, right, we'll return the mid. If not, means less than target, then we'll update our left is mid plus 1. If greater than target, then what we will do, right, we will update mid minus 1, okay? And we'll repeat these steps until we'll find. If we are not able to find, means we will return -1, that target is not available. Coming back to here, let's understand implementation. So in the implementation, sorry, we'll take what, integer. So integer is left, right, and we'll do -1, okay? I have actually updated this one int, this is our int, okay? So left is 0, right is last index, and so that we'll check if left is less than equal to right, and we will update our left and right, correct, each time. First of all we'll find our mid, how, left plus right minus left. This is nothing but, let's suppose we have some index we have given, right? And index we will take let's suppose left is 0, okay, right is what? 7 minus 0 by 2, that is 3.5. Similarly, same value that we are talking about. So it will find mid. We'll check the three conditions that we are talking about. If mid at target is matched, then we will return mid as an index. If not, less than target, then we'll update our mid plus 1, and mid plus 1 will start from here to, it will come to mid is here, let's suppose, and left is here, right? This is your left, this is your right, and this is your mid, right? So now mid is moved to here, next position. Mid plus 1 is this position, right? So now left is updated mid plus 1 if target is less than search item is less than. Then otherwise what we'll do, we'll update. If this is not the case, then we will update our right here, mid minus 1, this position. So either it will go here, or either it will go here. Okay, so three conditions are there that we have seen, right? First of all, we'll check if the we will find our what, mid. We will go to the mid. We'll check if num at mid is equal to target, means we have find the search. Then we will return this mid index. If not, then there will be only two cases. The first is mid is less than target, right? So we'll update our left. If not, then we will update our right. If we are not able to find the element, then we will update this one. So this loop will work until the last index. Okay. So as you can see, we have run this program. So I have got this input, and we are getting 9. So we are getting 4 here. This is 5, right? And if we'll talk about the algorithm, right, complexity, this is O log n, because see, we are dividing this array. Let's suppose we have this array into half if it is not matching, right? So in the worst case scenario, what will happen, we'll cut num until we find. In the worst case, it will be here, this position, right? But it can be at the mid, it can be near to the mid, it can be before the mid. So that's why it is log n, it is coming, right? So it takes only to reach the break conditions, right? We are not taking any extra spaces. This is constant space, so we only need 3 indexes, left, right, and mid, and it takes constant space, right? So it will become O of 1. So I think you got it, and if you have any doubt, please ping me in the comment box so that I will help you there. Okay, thank you guys, thank you for watching.